All right, guys, it's your FRQ helpful hint video. We're going to be going through these FRQs here. Now, as I go through this, basically, I'm going to I'm just going to do this one for you, and I'll probably do this one for you guys also. If you could do these two, you should be able to do 2005 and 2009 on your own. For 2012 and 18, I'll give you guys some helpful hints on those particular videos. So let's go ahead and we'll get started here. Let's start off with the 2016 FRQ here. So it says rocket A has a positive velocity after being launched upward from an initial height of 0 feet at time t equals 0. The velocity of the rocket is recorded for selected values of t on the interval from 0 to 80 seconds as shown in the table above. So what we have is a rocket that's been launched into the air. It's been in the air from 0 seconds all the way up to 80 seconds. And what these numbers here represents is the velocity of the rocket at any given time. So it starts off slow, faster, 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 faster. So that the velocity is just increasing more and more and more. It must have some kind of an engine on it or something, right? So part A is asking us to find the average acceleration of rocket A over this time interval. And they want us to indicate the units of measure as well. So we want to find the average acceleration of the rocket on the interval from 0 to 80, and we want to give the units of measurement. Okay, well, they're asking for acceleration, and this table is velocity, and it's an average. So the average acceleration is going to be the slope from 0 to 80 of the velocity function. Because remember, the acceleration is the derivative or the slope of the acceleration. Now, since it's asking for an average, we're not going to do derivatives. We're going to do a regular old slope. So we have v of 80. You could tell from the table up there, when t equals 80 seconds, it's 49. And v of 0 is 5. And 80 minus 0 is 80. And so we're left with 44 over 80, which, you know, we could probably just leave our answer like that so that we don't make mistakes, but you can reduce it if you want to. 4 would go in there 11 over, what, 4 goes in there 11, and goes in there 20 times. But now we're not done though, okay? We've found the average acceleration. It's 11 over 20. However, they want the units, and don't be surprised, a lot of times the way they score you on these, on the FRQs, is they actually won't give you any points at all if you don't put the units of measure. So we have velocity on top, and we have time on the bottom. So our units for velocity are feet per second. That's the top. And then on the bottom, we have time, which is seconds. So the way that you would write this is you would say that there's two ways you could write it. You could say it's 11 over 20 feet per second squared, or you could say it's 11 over 20 feet per second per second. Okay? Either one of those are good answers to use. All right, so let's go ahead and take a look at our next question. This is 2012, 1A. The directions say a graphing calculator is required. I don't think we're going to really need it, honestly, but technically you could use one on this. The temperature of water in a tub at time t is modeled by strictly increasing twice differentiable function. These words aren't too horribly important to us right now. Twice differentiable, we're not going to sweat too much here. But strictly increasing just means that the temperature is going up and it never stops going up. It's not like it goes up and comes down or anything, just strictly increasing. But anyway, so the temperature of water in a tub at time t is modeled by a strictly increasing twice differentiable function W, where W of T is measured in degrees Fahrenheit and T is measured in minutes. At time t equals 0, the temperature is 55, which you can see from the table. The water is heated for 30 minutes, beginning at time t equals 0. Values of WT at selected times t for the first 20 minutes are given in the table above. So there you go. Basically, we just have a bathtub being heated, and as time goes by, the temperature goes up. Okay, so use the data in the table to estimate W prime 12. Show the computations that lead to your answer, and using the correct units, interpret the meaning of your answer. So we need units and an interpretation. So we're going to find the answer. We need to show our work for our answer. We need to give units and then explain what it means in the context of the story problem there. Okay, so there's a lot going on. First of all, they're looking for the rate of change. That's an instantaneous rate of change. Now, you can't actually find the rate of change, but you can estimate the rate of change by finding the average rate of change. Now, how would I find the average rate of change to estimate what the instantaneous would be at W prime 12? Well, W prime of 12 can be estimated to be the average rate of change of the two values of t that are closest to 12. So if I look up here in t, and I'm looking for where 12 would be somewhere in here, right? So these are the two data points I'm going to use to estimate what the instantaneous rate of change would be at t equals 12. And so we're going to do W of 15 minus W of 9 over 15 minus 9. And W of 15 is 67.9. And W of 9 is 61.8. And 15 minus 9 is 6. And then we go ahead and do our subtraction there. We get 1, 6.61, 6.1 it looks like, over 6. And there you have it. I'm going to go and leave my answer like that. You could technically change it into a single decimal number if you wanted to do the division. It's not necessary though. Remember, you don't have to simplify on FRQs. You just have to make sure you show your calculus, and that's done. So I've accomplished my task. I've estimated W prime of 12, and I've shown the computations. But now I need to give my units. Now, W is degrees Fahrenheit, and that's what we have on the top of our fraction. So we have degrees Fahrenheit, and then time is what's on the bottom, and my time is in minutes. So that's degrees Fahrenheit per minute. And there's that. Now they also, but that's not good enough. They want us to not just give the units, but they also want us to interpret it in the context of the story problem. So what does this answer mean? Okay, what does that mean? Well, remember how they said the temperature's going up? Well, we're finding an instantaneous rate of change. And so what this means is that the temperature of the bathtub is increasing at a rate of 6.1 over 6 degrees Fahrenheit per minute when t equals 12. So here's how you would interpret it. I'll label this interpretation. Ready? The temperature is going up. Well, I guess we should say increasing. Sorry. And by the way, I would say that it's increasing because it's a positive rate of change. The temperature is increasing at a rate of 6.1 degrees Fahrenheit, or sorry, 6.1 over 6 degrees Fahrenheit per minute when t equals 12. Okay? And I guess you could say technically, since it's not really the instantaneous rate of change, it's just an estimation, we could say the temperature is increasing at a rate of approximately, you could say. Now, how would they grade this? Well, the last problem, what I told you, I looked up the answer key afterwards and how they graded, and I was right. They don't give you a point for your work and a point for your answer and a point for the units. They actually make this part here all worth 1 point. Okay, so if, in other words, you could get 6.1 over 6, and if you leave out the degrees Fahrenheit per minute, you don't get that point. There's no half points or nothing like that. So it's a package deal. You have to have that whole thing there. Okay, my guess is that on this one, the interpretation would be worth another point. Now, it's important to understand when you have an interpretation, you need some things in there. You have to have your output units. You have to have your input units. I probably should have put minutes here just to be safe. So we have our output with units, our input with units, and then we have our context. Anytime you're doing an interpretation, you need those three things. You need context, a little something you might want to write down on your FRQ. You need context, you need input, and you need output units when you do an interpretation. Okay, that's important. So my guess is that how they would grade this one is, like I said, 1 point for the answer with the units and the interpretation with those three components involved. Okay, so that's that. So that takes care of those ones. We're going to move on to the next part, which was 2012 C and D for, remember, I think it was 4? No. There it is. So we're going to, yeah, there it is. Okay. So now we're doing 2012, number 4, C and D. Okay. Now I'm not going to do these problems for you, but I'll give you some helpful hints. That's what the video is all about, right? So first of all, here's f of x. Now on part C, they're giving us a piecewise function where this is the function we're using for anything where x goes from -5 to -3. And then this is the function we're going to use for anything from -3 up to +5. Okay? Now the question is it continuous at x equals -3? Use the definition of continuity to explain your answer. Okay? So basically what you'll need to do is you'll need to find the limit of g of x as x approaches -3. You'll need to find out what g of -3 is, and then you need to make sure they're equal. Now that may sound easy enough, but here's the problem. This guy is a little bit deceptive. On a piecewise function, you can only find the limit if you are willing to do the limit from the left and from the right. And they have to come out to be the same. If they don't come out to be the same, then this does not exist anymore, and it's not continuous. But I'll leave it up to you guys to do this to determine if the limit exists, and then find this and make sure they're equal. So here's the deal. If this exists and this exists and they are equal, then you're going to say yes. And here's your explanation for why it's continuous. However, if you're trying to do this up here and you find these two aren't equal, you would say, nope, it's not continuous because the limit doesn't actually exist. Okay. Now, technically, it could fail to exist if g of -3 doesn't exist, but I know g of -3 exists because there it is. That means we could plug in -3. I know that's going to work. So the only thing that could possibly fail is this thing. So I'll let you guys do that footwork. This here, part D now, is a hearkening back to Unit 2. It's an integral problem. It's basically a U sub problem. Your U is this, okay? So use that as your U, and don't forget to change your limits of integration in terms of U as well, okay? So that's as much of a hint as I'm going to give you there. All right, let's go ahead and move on to the last helpful hint for the 2018 number 5 question. All right, so for the 2018 number 5 question, we're going to be doing part D. Once again, I'm not going to do this one for you. I'm just going to give you a couple of helpful hints. Now, here's my f of x function, and down here in part D it says let g be a differentiable function, which means you can find the derivative of it, such that g of pi over 2 equals 0. The graph of g prime is given below, so here's my graph of g prime. They want us to find this limit. Now I'm going to tell you, you're going to do direct sub. And after you do direct sub, you're going to use L'Hopital. But remember, I showed you guys how you have to write your answers when you're going to use L'Hopital. Don't put equals 0 over 0, okay? We say it yields the indeterminate form 0 over 0, so don't forget that. Okay? And so we say, therefore, by L'Hopital, then you go ahead and apply L'Hopital. Okay? Now, when you apply L'Hopital, you're going to have to take the derivative here on the top and the derivative here on the bottom. Now, when you take the derivative on the top, you're taking the derivative of this. F prime is going to need the product rule. Okay, so don't forget about your product rule. And as far as G prime goes, you're just going to use the graph. So, you need to find out what G prime is, right? That's your graph. Then you're going to plug in pi over 2. So you're going to find out what is G prime when we are at pi over 2. So at pi over 2, G prime would be 2, just so you know. Okay? And that's pretty much it. I'll let you guys go ahead and do the rest there. My guess on how they would grade this, I'm not sure if I have the version that has the scoring guide on here. I don't. My guess on how they would grade this, though, is I would guess that they probably would give you a point for using L'Hopital, and then probably give you a point for finding the correct answer. Okay, so it would seem to me to be about a 2-point question. All right, so hope that was helpful, and we'll see you guys later.